Hello all, we are undergraduate group 1. We will be discussing non-destructive testing of steel structures. The topics that will be discussed are deficiencies in steel structures, basic non-destructive tests, advanced non-destructive tests, case studies, and we will have a conclusion. As we all know, steel is widely used in structural applications like bridges, buildings, and because of its widespread use, it is important to ensure integrity of members and structures to protect the health and safety of users. NDTs are an important tool in that evaluation of members and structures. Admittedly, there is some ambiguity between the identifiers of basic and advanced. What is advanced today may be considered basic tomorrow as improvements and developments are made. Some deficiencies in steel structures, such as poor welding, can result in ineffective joining of steel members and provide poor structural integrity, as you can see by this image of a steel skeleton of a building that failed in compression. Some poor welding practices, such as neglecting nitrogen loss, can lead to poor corrosion resistance, nitrogen pores, and cracking. Furthermore, poor construction and structural analysis or design can also lead to failure. However, it's important to note that steel failures do not always result from poor construction or analysis only. For instance, steel production itself can result in material deficiencies that reduce its effectiveness and may result in a shorter than expected design life. Non-metallic inclusions, or NMIs, which are a product of chemical reactions and basically just occur during the melting and pouring process. They have a large effect on material properties such as strength and ductility. Inclusion engineering is a production method that aims to enhance certain steel properties through the development of specific inclusion types. There are some classifications of NMIs that do exist, but they are rather arbitrary due to a lack of standard criteria. NMIs can cause microcracking, which may reduce some protection. This is an image here that shows a steel wire that failed during processing due to a large NMI. Another deficiency that can develop is hydrogen-induced cracking, which is a naturally occurring chemical reaction, but it can result in fracturing, especially in your welds. Also, research actually suggests that NMIs can lower resistance of HIC. NMIs may also have an impact on tensile void development, which can result from plastic strain and can lead to crack propagation, like this image shows. Because the deficiencies discussed may result in failure of a member or structure, evaluation and assessment are vital to ensuring public health and safety. NDTs are an important tool in this evaluation. One of the most basic NDTs is just visual inspection, which is the first step in determining which NDTs may be needed and is a general assessment. Furthermore, ultrasonic pulse velocity test uses the relationships between speed and time to determine variations in a material's thickness. This test can show where defects such as cracks are in the material. Another NDT is dye penetrant testing, where you apply a penetrating liquid. It's a very straightforward test, but it's highly effective. Basically, it takes time for the liquid to penetrate and through the material. This time does vary based on temperature and thickness, but it can show where the cracks may be developing. An advantage is that it can be used on numerous steel types. However, one major disadvantage is that there's the possibility of health hazards from the toxic chemicals, so proper safety practices do need to be adhered to. Sarah will now be discussing some more NDTs.
Thanks, Nate. So another NDT is ER, or the electrical resistance probe method. This method compares the electrical resistance between a test area suspected to have corrosion and a reference area on the same member known to be unaffected by corrosion. The difference in electrical resistance is used to locate the areas of material loss, and to perform this NDT, a probe, power supply, balance resistor, and amplifier are required. This NDT is useful because it can be used on steel in the presence of gases and non-conductive liquids. Magnetism is also a basic NDT. As shown in the picture to the right, a magnet can be used to measure magnetic flux, which shows structural discontinuities in a steel specimen, as well as stress levels in welds. Next, we have advanced NDTs. The first one we studied is phased array ultrasonic testing. Phased array is similar to ultrasonic pulse velocity because a beam measures the speed of sound waves passing through the medium to determine its elastic properties, except as shown in the picture below, this method can achieve a more customized scan. Phased array makes angular scanning possible for geometrically complex structures, allowing for a more thorough scan compared to the conventional ultrasonic testing. Radiographic testing is another popular advanced NDT, and digital radiography, as pictured in the photo to the right, uses X-rays and gamma rays to penetrate the steel. A sensitive film collects the levels of radiation on the other side of the material, and the differing levels indicate locations of defects. Similar to digital radiography is radiometry, which replaces the radiation film with a radiation detector and measuring instrument. While this can be deemed safer than its sister NDT radiography, because its source of radiation is typically 100 times less, it's still hazardous. Next, we have infrared thermography. As pictured to the right, this method uses an infrared camera to measure temperature, and the changes in temperature indicate gaps or defects. This method is great because it records images really quickly, but it does require time to perform image processing as well as a required camera operator. Electromagnetic acoustic transducers uses a magnetic coil, which generates and receives ultrasonic waves. It's based on Lorentz forces, which are forces created from disturbing the balance in electrons by applying a static magnetic field. The changes in the balance are translated to an elastic wave, which creates an ultrasonic picture. And this NDT is great because it creates a higher resolution image compared to other ultrasound methods. Lastly, in the advanced NDT category, we have a remote field testing bracelet. This probe is shaped like a bracelet to wrap around steel structures to inspect the full circumference of the interior. The probe bracelet transmits a low-frequency magnetic field throughout the tube that creates a scan, and the scan is measured by a ferroscope instrument, which generates a high-resolution color photo of the interior where variations in thickness are made visible. Next, we have Saja talking about different case studies.
Okay, thank you, Sarah. Okay, so the first case study would be, we will look at, hold on, let me restart. The first case study we will look at is Seto Ohashi bridges, where non-destructive testing was performed to indicate fatigue areas. Thermoelastic stress measurement technique using infrared thermography were used for repair, where measurements were taken at various stages of repair to determine the most effective methods, explained on the next slide. So we have a circular arc cutout method and a stiffening plate method. Finite element method analysis was used to analyze each method and predict which method would most effectively redistribute the stress away from the weld. These images show the stress measurement at different stages of the repair. It was seen that the circular arc cutout method reduces the stress, while the stiffener plate method is actually increase the stress at the weld. Next case study is about a 3-story reinforced cement concrete frame of an overhead water tank in Pilani campus in India that has been standing for approximately 40 years. The issue is that there was a visible development of wide visible cracks and rusting of steel reinforcement that indicate the need for NDTs performed. Multiple NDTs were used to assess the infrastructure, which were visual inspection, rebar locator, half-cell potential tests. These tests show signs of rusting of steel reinforcement, and specifically HCP showed the high level of corrosion experienced by the structure. Next case study, we have the Act Marine Split, which is a reinforced concrete structure located in Croatia, that experienced corrosion due to aggressive marine environment exposure for 30 years. Multiple NDTs were performed, such as visible inspection, ACP mapping, mechanical and chemical testing, that indicated the only available solution was to construct a new marine with a corrosion protection applied to prevent the reinforced rebar rusting due to the severe environment. Next, we have the 60 years old rectangular reinforced concrete water tank built over the terrace of an office building that was constructed in 1915 in India. Visual inspection was performed to observe different levels of steel corrosion. Um, and it, oh my God, how about, oh, visual inspection determined repairs were needed. Highly corroded reinforced was removed and replaced with a protective coating that was then applied to the new reinforcement. Next. Okay, and finally is the Shell Petroleum Development Company in Nigeria. It is an interesting case study to look at when looking at NDTs performed to discover defects. The company experienced oil leaking problem frequently due to corrosion of steel pipes and fitting. Therefore, visual inspection and ultrasonic wall thickness measurements were then taken. Detecting a reduction in wall thickness due to corrosion caused by the surrounding environment condition. The solution was repair the elements and apply corrosion prevention measures. And finally, in conclusion, steel is a very important building material. NDTs are important to evaluate structures. Case studies provide a real-world examples on how NDTs is performed and help improve design guidelines. Okay.